Hello and welcome to today's algebra lesson. Today we're going to talk about using a graph to identify intercepts. Intercepts are a point at which a curve, or in this case we'll be talking about lines specifically, crosses either the x-axis or the y-axis. Where a line crosses the y-axis, we call that the y-intercept. Where a line crosses the x-axis, we call it the x-intercept. So, we can see equations of lines in a couple of forms. This is called standard form. And if you have some number times x plus some number times y equals some other number, you get a line. Now, a can be 0 or b can be 0. They just both can't be 0. So you could just have like 3y equals 9, and it's still a line. It's a special kind of line. It's a horizontal line. But this is called the standard form of the equation of the line. The other way you're used to seeing this is like y equals 3x minus 5, or in slope-intercept form, as we'll get into in the next couple of sections. So to graph the equations of any form, but particularly of this form, you just need 2 points. And of this form, the 2 points you use to graph them are the x-intercept and the y-intercept. So it's important that you know how to find them when you're given the equation. You only need 2 points to graph a line, and it shows you where the entire line is. So the intercepts are fairly easy to find. Those are 2 good points to use. Find the point where the graph crosses the y-axis. Find the point where the graph crosses the x-axis. Put them on the graph and then connect them, and you'll have your line. Oh, I think I went too far here. Sorry. All right, so x-intercept over here. See, this line crosses the x-axis. This equation is not in standard form. This is y equals 4x minus 8. And it crosses the x-axis where x is 2. And when you're on the x-axis, you've moved right 2 from the origin, but you haven't moved up or down, so the y-coordinate is 0. That is going to be true for every x-intercept. The y-coordinate will be 0. So 2, 0 is a solution to this line also. If I replace the x with 2, I get 8 minus 8, and that is 0. 0 equals 0 will be true. But looking at the graph, you literally are just looking for this spot where you cross. Where you cross the x-axis, and that's your x-intercept. The number on the axis at which you cross is the x-coordinate, and the y-coordinate is 0. So, the y-intercept. Up here where you cross the y-axis. Okay, so that looks like it's at, so I don't go left or right. Notice the x-coordinate is 0 when I'm on the y-axis, and that is up at y equals 4. So the y-intercept for this is the point 0.04. Sometimes in your homework you'll just have to type the number 4. You have to look to see what form they want. If they say give the point, then you want to do the 0, 4, but if they say what is the y-intercept, sometimes they just want you to type 4. So be aware of that. So this, if I put a 0 in for x, 3 times 0 will be 0. That goes away. Anytime one of your variables is 0, the whole term it's with, 3 times 0 will be 0, goes away. And I get y equals 4. That's and sure enough, 4 equals 4. So this is also a solution to the equation. All right, so here, looking at a graph, here's one of the things you need to be able to do, is find an x-intercept and a y-intercept. If I want to find the x-intercept, I look and see where the graph crosses the x-axis, and I find what that point is. The x-intercept is at -3, so the point is -3, 0. Often your homework will just want the -3, and I just did that by starting at the origin, and I see I'm going to the left, so x is negative. 1, 2, 3. That's where I cross. The y-axis, you start at the origin, and you count 1, 2, 3, 4, 5, 6, 7, 8. Hopefully that's 8. Oh, sorry, no, that's not 8. Sorry, it's 5. 1, 2, 3, 4, 5. And on the y-axis, I didn't move left or right, so x is still 0, and y is 5. So the y-intercept is 5, which happens to be the point 0, 5. Your homework will probably just want the 5 for most of it, if I'm remembering correctly. All right, this one's a little different. I look here, and I'm crossing the x-axis here. And x is 0 there. And y is also 0 there. When your line crosses the origin, both the x and y intercepts are 0. That's the only time they'll be the same, is when they're both 0. So the the x-intercept is 0, the y-intercept is 0, the x-intercept point is 0, 0, the y-intercept point is 0, 0. So this won't help you graph this particular line because you will only have one point. When the intercept comes out at 0, 0, then you're going to have to find another point to make the graph. All right. So the pattern I'm hoping you hear me say is that when you have a point that's on the x-axis, the value of the y-coordinate is 0. And when you have the y-intercept or a point on the y-axis, the value of the x-coordinate is 0. I remember when I was learning it, that was something when it finally sunk in, that became quite useful. So I thought I'd put that right out there. You might not quite get it yet until you start to work with these, but remembering that if the point is on the x-axis, you know the y-coordinate, you know it's 0. Or if the point is on the y-axis, you know the x-coordinate, you know it's 0. That does become helpful. So we use that piece of information to take an equation and find the x-intercept and find the y-intercept. If I'm looking for an x-intercept, I'm going to replace y with 0, and that'll get rid of the y in my equation because it'll be 0, and I'll just have x in the equation, and I can solve the equation to find the x-intercept. So I solve it for x. Here's an example. To find the x-intercept of this equation, I'm going to replace y with 0. The equation is 5x minus 2y equals 25. When I do that, I get 5x minus 2 times 0 is 0. So this term goes away. The y term goes away. This term here goes away when you make that y 0. You're just left with 5x equals 25. You would divide both sides by 5 to isolate the x, and you get x equals 5. So the x-intercept is 5, or the point 5, 0. You chose y to be 0. That's the other reason it's 0 here, but because you know you're on the x-axis, it's also 0. We use this same technique to find the y-intercept. It's just instead of y being 0, we replace x with 0. And then we solve for y. So here I'm going to replace this x with 0. And so this whole term becomes 0, and I get negative 2y equals 25. Whoops, I have a mistake here. I dropped the negative. Don't do that. I see that happen so much, I must be starting to do it myself. This is a negative 2y here equals 25. This should be a negative 25 halves when you divide both sides by negative 2. And all of these should be negative numbers. All right, so keep in mind that I dropped the negative 2y, which is really bad because students do that all the time, and you're not supposed to do that, okay? So maybe you'll remember better now, I hope. All right, so that's objective 2. Now, what happens when you're asked to graph a line, but there's not an x and a y in your equation? How do you like to graph a line, you find 2 solutions or maybe 3, and you plot those points and you draw it. But what if, you put in an x and there's no way to calculate y, or you put in a y and there's no x? You get these 2 special cases. If you get an equation that says y equals some number, y equals 5, that means you have a horizontal line because no matter what x is, y equals 5. So if x is negative 3, y will be 5. If x is 0, y will be 5. If x is 10, y will be 5. And if you connect those dots, you get a horizontal line. The other way to think of that is y is always 5. And make up some points where y is 5 and just put random x-coordinates in and then plot those points, and you'll see it goes this way. The big problem with this is y equals a number. Students get it confused with the y-axis, which goes this way. Y equals a number tells you the number you cross the y-axis, and you just keep going left to right. If you have a line, you're told it's a line, and you only have x equals a number, x equals negative 4, for instance, you have the point x is negative 4, 0. You also have the point x is negative 4, 2, x is negative 4, 5. Y doesn't matter. So for every single point on your line, x is whatever a is, and I'm saying negative 4 for this example. And you just make up a list. I'm going to plot the point negative 4, 0, negative 4, 1, negative 4, 2, because y doesn't matter. So you put in some random y's, plot those points, and that gives you the direction of the line. The x equals a number is what we call perpendicular to the x-axis. It cuts through the x-axis. That might be another way to think of it. Y equals a number cuts through the y-axis. That might be another thing. So this becomes very important. These are the special cases, but they are important special cases. So if I'm asked to graph y equals negative 4, here's the way I like to have students do it is you make some points. Say x is -3, what's y? Well, if x is -3, y is -4 because y is always -4 is what that means. So pick some values for x. You could pick 0, 1, and 2. It doesn't matter. But y is going to be -4. And when you do that, you pick these x values, and for each of them y is -4. You plot those points, and it gives you the direction of the line. If you can't remember that it goes through the y-axis horizontally, just by looking at that, then you can force yourself to see it by making some points with y is -4 and x are a couple of different things, and plot them, and you'll get the direction of the line that way. X equals 5. Same thing. This time you have to pick some y's, but say x equals 5, just y can be anything. Y is 2, y is 7, y is 9. Pick some things that are easy to plot. So pick x is 5, y is, in this case we pick -3. X is 5, y is 1. X is 5, y is 5. When you plot those 3 points, then you'll see this is the direction of the line. It crosses the x-axis at 5. It cuts through it at x equals 5, perpendicular to the x-axis. All right, so ordered pairs that are solutions of y equals 3 always have the y coordinate is 3, and it doesn't matter what x is. So you fill in a couple points and make the y coordinate -3, fill in a couple of random x's, and graph them, draw them that way if you're given y equals 3. If you see a horizontal line and you're asked to write the equation, what you might do, what I would do, is pick 3 points. So you say, okay, I see this point is 3, 3, this one's 0, 3, this one's -2, 3. And the pattern you see is that y is always the same. Whichever letter is always the same is the letter in your equation, and the number that it's equal to is the number on the other side. So, same thing for x equals -2. X is always -2. Now, if I were given this line and asked to give the equation, well, you say, well, I know it's one of those special cases, but again, I would, if I didn't have these points already written out, I would pick some points, write down the coordinates, and I would notice the pattern is that the x's are always the same, which means x is the letter in your equation, and x is always -2. You can read that equal sign is always. All right, is this it? I think that's it. So that's what we're doing in this section 3.2 is we're looking at intercepts, x and y intercepts, in horizontal lines, which have equations y equal a number, and vertical lines, which have equations x equal a number. I will put some examples up to go along with this, and I think you have enough to get started on your homework now. Email me any questions you have. Thank you.